Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 27 of the November Daily LeetCode Challenge. We have just 3 days to go to get the badge of the November Daily LeetCode Challenge. And as you might be knowing, from the last 2 days we had questions on graph, and today again we are having a question on graph. This is a very good question. So, like if you see the level, the first question was slightly easier, second question was even easier, and now this is again like just following the level. It's slightly difficult. Here you will have to do BFS along with, like, you have to use a graph traversal algorithm along with some other thing. Okay, so that is what the question is, and let's see it. Okay. So it is question 3243 and shortest distance after a road addition queries. Okay. So if you see here basically what is happening. Just a second, yeah. So as you can see, these are the graphs. Okay. Initially, what they're saying is there is always this already a node present. For example, 0 to 1, 1 to 2, 2 to 3, and 3 to 4. So that is for every node there is a edge present to its next node. Okay. So yeah, they have given n. So n means the number of nodes. Okay. In that is 0 to n minus 1. So for each node there is an already edge present from that node to its next node. Okay. 0 to 1 already node is present. Okay. Like that they're giving. Now they're giving certain queries. What are those queries? Those queries are going to be the additional edges that are going to be added after each for each query. Okay. So what you have to do is, for example, when I'm executing this query, so what I have to do, in addition to the edges that is already present, for example, 0 to 1. Okay. So for every number the edge is present to the next number. Okay. That is already present. Apart from that, we will have to add this, for example, to process the this query, I will have to add this edge, and then I will have to find the shortest path from 0 to n minus 1. Okay. Similarly, for the answer of this, what I have to do, I have to add these two edges, and then I have to find the shortest path from 0 to n minus 1. Similarly, for the last query, what I have to do, I have to add all these edges, and then I'll have to find the shortest path from 0 to n minus 1. Okay. That is the question, and this are the shortest path. Okay. For each query, we have written an answer. So let us quickly see the question now. You are given an integer n and a 2D integer queries. Okay. So there are n cities numbered from 0 to n minus 1. Initially, there is a unidirectional road from city I to city I plus 1. Okay. That's what I mentioned. For example, the n is 5 means, so 0 to 4. Okay. 0 to 4, there are nodes. So already there will be an edge present from 0 to 1. That is from each I to I plus 1. Okay. As simple as that. So that's what they're trying to say. For each I to I plus 1. Okay. Unidirectional. That means only one directional. Remember, it's not like you can traverse back. Okay. That is not allowed basically. So you have to keep that in mind. It's a unidirection. You can only go forward, you cannot come backward. Okay. Similarly, queries of this thing. Okay. You can call it u comma v. So that is, each query is kind of like this, a single array, that is a 1D array with two elements. U comma v represents the addition of a new unidirectional road from u to v. What is unidirectional? It basically means that it's a directed graph. Okay. There is a direction for each edge in this case. Okay. You can see the, if you zoom in, you can see the direction for each edge. Okay. That is what they're trying to tell. Okay. So each query is actually having a direction. That is, this particular query is from 2 to 4. Okay. 2 towards 4, as simple as that. You cannot come the other direction. Okay. After each query, you need to find the length of the shortest path from 0 to n minus 1. Return an array answer where each I in the range. Okay. Like this. Okay. That is for each basically query to give an answer. Answer I is the, see, this part is important. Answer I is the length of the shortest path from city 0 to city I minus 1 after processing first I plus 1 queries. Okay. As simple as that. After processing those many queries, what is the answer going to be? Okay. So yeah, just see this part. Let us see the example one first. So what is happening is, you are given the road. Okay. What you have to do first, one thing is very clear. Even before we start processing the queries, one thing that is clear to us is every node I is connected to I plus 1. Okay. There is edge from I towards I plus 1. Okay. That point is very, very clear. After that, to find the answer of this query, what I have to do, I have to add an edge between 2 to 4. Okay. So currently this is how my graph is going to look when I am processing the first query. So what is the answer going to be? The answer is going to be the shortest path from 0 to 4. So what is going to be that? I will go from 0 to 1, and then 1 to 2, and from 2 to 4. Okay. So the answer is going to be 3. So that is why the 3 is marked here. Okay. As simple as that. Now let us come to the second query. It is from 0 to 2. Okay. So if you see, this edge will be retained when I'm processing the second query. The edge introduced by the first query will be retained. So if you see the graph for the second query, this is how it will be looking like. Okay. So a new edge from 0 to is added. The previous edge from 2 to 4 is already retained. Okay. So in this case, if you talk about the shortest distance from 0 to n minus 1, it is going to be 0 to 2 and then 2 to 4. So only two passes are needed. Okay. So the answer is going to be 2. Okay. So these are the shortest paths. So if you see the question basically, see here the edges are not having a direction basically. Okay. So try to understand this point. The edges are not having the edges are not having a weight here. Okay. So all the edges are having same weight. You can take it like that. Okay. Just a second. Let me zoom out. Yeah. So yeah, that is what basically they are saying it. Yeah. Just a second. Yeah. So we process the first two queries, and now we are going to go for the third query. Okay. So that is adding edge from 0 to 4. If you see here, this is how the graph will look like for the last query. So if you see, there is directly edge from 0 to 4. So basically, we need only one pass to reach 0 to 4. Okay. There is just one edge. We have to traverse only one edge to reach the end node from the starting node. Okay. So this is how my answer array will look like, right? And yeah, that is all about this question. And second example, you can go through it. Okay, that again simple. In this case, what is happening is, in the starting itself they're having 0 comma 3. That means directly they're introducing edge from the first node to the last node. So all the answers after that will be one only. Okay, as simple as that. So that is the basic idea. And if you talk about the constraints, n is going to be fairly low. Okay, it's slightly low. And query's length is also going to almost up to 100, sorry, 500. This part is pretty clear. And here what they're trying to say is that, see, there are no repeated roles among the queries. Okay, there will never be a repetition. Okay, that is something that see, these are the reasons why this question is on the easier side. Okay, that's what I would say. And this thing is trying to tell that, the for example, if you see in this particular thing, the this one, okay, this will be always smaller, and the second element, that is the index one, will be always bigger for each element. Okay, that is what they're trying to tell through this. Okay, and you can go to the other constraint as well. So they are trying to tell that if you subtract the two, okay, it's almost always going to be greater than one. Okay, that is, there will never be self edge. Okay, this is what they're trying to tell through that. Okay, there will never be a self edge. It will always be greater than one. So yep, it always greater than one means, see, already see, for example, 0 comma 1 already edge is there, right? So we need, see, that will not be coming. That's what they're trying to say. There will never be self edge. At the same time, there will never be edge from node to the next node, because that is already there, right? So that's what they're trying to tell through that. Okay, and none of the routes are yeah, you can go through that. Fine. Now, coming to what our solution will be, see, solution is going to be very simple. We have to maintain the graph, we have to keep adding the edges, and for each query, basically we have to do iteration to find the answer. Okay, as simple as that. So what we'll do, we are in my question solution, basically I'm doing a BFS to find the answer. Why BFS? See, BFS doesn't make sense here. If you see the way the things are happening, for example, once I reach 2, I will reach the answer. Okay, so BFS according to me makes more sense here, because if you do a DFS, that doesn't make sense according to me, because there is no need to go to the depth of one side when we can get the answer, pretty, much earlier. So that doesn't make sense to me to do DFS here. Okay, so I will be doing the BFS. Let us see how do we progress here. Okay, so see, idea is going to be very very simple. Let me explain the idea first. I am defining a BFS function. Okay, what I will do, I will pass the graph to that. Okay, it will return me the path from 0 to n minus 1. Okay, the shortest path from 0 to n minus 1, that is going to return me that. Okay, so what I will do, I will keep adding the edges to my graph, and I will be keep adding the answer that is being written by this BFS function. Okay, as similar as that. So if you see the setup, what I've done. Okay, let me do this part. Yeah. So basically, I'm first of all doing the initial part. What is that? For each node I, there will be edge towards I plus one. Okay, that part I'm first doing. Okay, then so this is going to be how my graph will be looking like. Okay, let me print this also for you to understand very clearly what is happening. So I will just show you how the graph is going to look like. Yeah. So if you see, this is how the graph is going to look like. Sorry, not this whole part. Only just a second. Yeah. Only this part. Okay. That is, each key will tell me the starting node, and each see, the value for each key is going to be array. Okay, a list that will tell me from that particular node how many edges are going towards other nodes. Okay. That is, for example, here from 0, a edge is going towards the node 1. Similarly, from here, a node 1 edge is going towards node 2, and so on. Okay. So for example, in the later part, let's say one more edge starts from 1 towards 3, let us say. So it will be 2 comma 3 then. Okay, that's how it will be. Fine. So it will look like this. And see, this is the done initial itself. So for each iteration, I will not do this again. Okay, as simple as that. So this is going to be my BFS function. I will come to this in a while. Before that, let us see the initial part. What I'm doing, I'm creating answer array, and then I'm going through each of the queries, that is u comma v of the queries. Here I'm calling them I comma j. This is printing is for you to understand that. What I'm doing, I'm just doing graph dot append is equal to j. Okay, that is, from there is a node, sorry, there is edge from I to j. Okay, so what I will do, I will just go to graph of I will append j to that. Okay, as simple as that. Because see, they've clearly mentioned there will be no repetitions, so there is no need for me to check that. Okay, I'm not checking whether j already exists or not. Okay, in graph of remember, graph of will look like this. Okay, it's a dictionary, basically it's a mapping in Python. Okay, and I've already shown you how it looks. Okay, this is basically a list. So to this list, I'm going to add one more value. Okay, as simple as that. I'm just doing graph of y dot append j. Okay, and then I'm starting the BFS, that is, I'm calling the BFS function. I'm passing the graph. This will return me the path to 0 to n minus 1, the shortest path. That will be append in my answer, and finally the answer will be returned. Okay, let's see how this function works now. So that's pretty simple. If you have been seeing my videos from last 2 days, I'm damn sure you would have learned this particular thing by now. See, it's very simple. Since I'm going through one layer deeper into another function, I am declaring the n as non-local here, basically. Then what I'm doing, Basically I'm not using n anywhere. Okay, but you can remove this part. Basically, if you need, you can remove this part because I'm not using n. Fine. What I'm doing, since we are doing a BFS, we will always require a queue. Okay, here I'm calling it a DQ. Why I'm calling it a DQ? Remember one thing: the append I'm doing, always it will be from the right, that is addition of elements will be from the right, but the removal of elements will be from the left, that is from the 0th index I will remove the elements. Okay, that is the reason why I need a DQ. DQ makes it O of 1 to remove elements from the 0th index. Remember, to remove element from the 0th index, you need a O of n, time complexity for a simple list. Okay, in Python, but you are having a DQ that it makes it O of 1. Okay, as simple as that. That is fine. I'm creating a queue. This is data structure is DQ, and here this is going to be my first element. Okay, this whole thing is my first element. What is that? Okay, let me zoom in. See, this whole thing is my first element. What is going to tell me? It is going to tell me that the path, that the node is 0, and the path to reach this node is 0. That is, yeah, the path value is also 0 and the node is also 0. Okay, as in when we reach a particular node, we will also record the path that we have to travel to reach that node. Path basically means the number of steps that we have taken. That is the number of edges that we have faced. Okay, the second value is going to tell me the number of edges to we have traveled to reach this particular node. Okay, and this is the node value. Okay, initially it will be 0 because it will starting from 0. I'm calling a visited set. This will tell me which all nodes are visited. One very good thing about BF is that, let us say you visited a node, let us say you visited the second node first. Okay, you should not be, if you visited a node, that basically means that is the quickest way to reach that node. If you see here in this second picture, basically what is happening, see, from 0 you are reaching 2. Okay, but remember, from 1 also you can reach 2, but since 0, from 0 I will be reaching 2 first. Okay, because it's a neighbor of 2, sorry, neighbor of 0. So what will happen is, once I reach 2, I will never be reaching there again. That is, from 1 also I can reach there, but since I'm tracking it to my visited array, so visited set, that will ensure that I am not reaching there again. Okay, because I know that once I've reached there, that is the best, that is shortest part to reach there. Okay, so if any other node is taking me to 2, I will not go through that. Okay, because once we reach, see, all nodes with a distance of 1h, I will be reaching first. So since once I've reached a node, if let us say in some other iteration I'm reaching there again, that doesn't make sense, right? Because we need only the shortest path. Okay, as simple as that. Then what I'm doing, I'm data in my path. Okay, this is not needed, by the way, just remove it. This is not needed here. Okay, fine. Then what I'm doing, I'm just doing visit dot add of 0. Okay, because I'm visited the first node, that's what I'm trying to convey. I'm printing the queue for you. Initially it will have only one element, which is like this. Okay, fine. Then I'm starting till my queue is empty. I have to do this. What I'm doing, I'm doing a queue pop left. That is from the 0th index, I'm popping it. So first node will be the node, that is the node, and this is the path, that is the number of edges I've visited, I've taken to visit this particular node. Okay, something like this. Okay, it will look like this. Fine. Then what I'm doing, I'm going through each of its neighbors. For example, see, this is where the graph is being used. Okay, so I will pass this particular node to my graph to get all the nodes which are adjacent to it. Okay, which are the neighbors of it. So what I will check, whether if the neighbors are not visited. Remember, if I visited the neighbor already, that means this path will be the longest part to that. Okay, I've already had a shortest part to that particular node, so I will not traverse them again. As simple as that. So what I'm doing, then this check will happen. Okay, I will come to this check later. But if a neighbor is not in my visitor, what I have to do, I have to append them in my queue. What should I append? I will append a single element. Okay, this will be single element. It has two parts. What is that? The neighbor itself and the path to reach that. I'm just doing path plus one. Okay, so whatever is the path to reach this particular node, the path to reach its neighbor will be just a plus one more. Okay, so I'm just doing a plus one, and then I'm adding it to my visited set. Okay, as simple as that. Then I'm checking if the neighbor itself is this is the target, right? We have to reach the last node, which is n minus one. If we have reached there, no need to add it to, no need to do all these things. Okay, I can just see that is the idea here is, whenever I first reach the target, whenever I first see the target, I'm going to return it, because that is the answer, right? That is going to be the fastest one. Okay, because remember, in BFS what happens is, you are traveling layer by layer. Okay, all the nodes which are at a distance 1, you will be traversing them first, then which are at a distance 2, you will be reaching them first. So the idea is, whenever we see the neighbor for the first time, that is the shortest path. Okay, so we'll have to return that. Okay, this will be returned. If this whole loop completes and we have not reached the target node, we have to return -1. This pretty much will never happen. Just for your information, I'm mentioning this. Okay, so I'm calling the bfs function here. After that, I'm again adding some of the edges here, and then again I'm calling it and recording the return value in my answer array. Okay, and finally I'm returning that. So let us analyze some of the yeah, some of the examples. So talking about the first example, so if you see here, this is how my graph is going to look like initially before we start exploring the queries. Okay, so this is how it will be looking like initially. Then what will happen, I'm going to add a edge 2 comma 4. Okay, so after adding the edge 2 comma 4, I will start the bfs. So this is how the bfs will look like. First it will have a 0 comma 0. Then from 0 comma 0, basically there's only one neighbor, so 0 comma 0 will pop out, and this particular thing will be popped in. Okay, that is element 1 is popped in, and the path, that is the number of edges to towers, that is going to be 1. Okay, then from 1 I will reach 2. Okay, yeah, I'm reaching 2 with the number of edges towers is 2, and then finally from 2 I will be reaching 4. The idea is once I reach 4, remember, I will return the answer. Okay, I will not continue in the query. Okay, remember that I will not continue in the that bfs function. That is why you will see that is not being printed here, but it will be written in the answer. Okay, as simple as that. You will see that in the answer. If you see the answer, it is going to be 3 in this case. Okay, fine. Next is, what is happening is, I am adding 0 comma 2. Okay, I am adding 0 comma 2. Just come to this part, I am adding 0 comma 2. So what will happen? Again, same thing. Initially only 0 comma 0. I am starting the bfs now. First node will be 0 comma 0 always. Then now this time there are two neighbors of 0. So both of them will be added. Okay, 1 comma 1 will be added and 2 comma 1 will be added first. Okay, since now from 1 I will try to explore its neighbor. What are its neighbors? And neighbor is going to be 2. But since 2 is already visited, that will not be added. So it will be simply popped out. So only 2 comma 1 will be remaining, and the neighbor of this is the answer, that is 4. That's why the bfs will stop at this point. Okay, fine. And then the last one, I just added it from 0 to 4. Okay, first node will be 0 comma 0. Since from 0 comma 0 I can directly reach 4, so I will break the bfs and return the answer, which is 1. Okay, you see, these are the answers. I've already submitted the solution and it got accepted. So Yafin, that was all for today. Again, like, this is slightly simple, so I'm not giving the Java solution separately. I'm expecting you to do it on your own. This is the only data structure that I'm using additionally. Other than that, everything is pretty much the same. Okay. Other than that, I'm not using anything which is special to Python or something like that. It is like very generic. You can add it in Java as well. Okay. So Yafin, that was all for today. If you like my efforts, please do subscribe to my channel. It really gives a lot of motivation to continue further in the journey. This was day 27. We are only 3 days remaining to get this particular badge, and I am assuming that this year you will be solving at least 100 plus questions in LeetCode. That should be your target. If you have not done that, please do that now, because you still have time. Okay, you still have around 30 plus days remaining. You can still add 30 to your number, and that will be recorded forever in your LeetCode profile. So that should be your ambition, and yeah, I hope my efforts bring some light to your journey. So yeah, that was all for today. Please subscribe. See you tomorrow.